All right, welcome back, everybody. This is now week 5, so we only have 2 more weeks left after this. Um, we've sort of done a lot with sort of static making images, using different tools, gaining different controls. And this week we're going to start looking at animations as well. So we'll dive into that very soon. We'll mostly be using this week a node called AnimateDiff. For those of you who are running local stuff, you might need to install it yourself. It's the AnimateDiff evolved node set. It comes pre-installed on Run Comfy. So anyone using Run Comfy, you're good there. Couple little class updates. So first off, Eric was kind enough to call me out in our Slack channel and mention that I was wrong and that it's not intellectual property adapter like we called it last week. It is instead image prompt adapter. I don't know how that got stuck in my head. I feel like someone called it a joke, like called it intellectual property adapter, and that just like stuck with me as like that must be real because it is kind of what it is. But it's correctly image prompt adapter. So I don't want to go and spread misinformation and piss people off. So there you go. Thanks, Eric, for catching that and rightly pointing out that they had a somewhat more benevolent name for it when they released it. I also put up a little video middle of this week. Alana, who's been in a bunch of our classes and is taking the async class, sort of asked me about how to do batch processing in ComfyUI. So basically, like if I want to run the same process over 20 images using image to image, or whatever, like using clip interrogator, like any of those sort of things, how would I do that? I still maintain batching is not my favorite thing to do inside of ComfyUI. It's still really not set up to like handle batches in the way that I would like in like a tool like Auto 1111, where you can really throw a lot at it. If you're looking 20, maybe 50 images, I think the tools in the video I talk about here is good. But if you want to process like a ton of information, I'm still not sure that the way it works in Comfy is that good. But there's a little video here with some workflows that people can download and check out if they want to look at that process. Okay, so there's a question from Alana in the okay. And then talking about next week. So Golan and a couple other folks were in the Q&A last week. And I kind of mentioned like I have an idea for maybe the first hour of next week's class, which will really be going into more animation details, doing something like video to video. But after that, we kind of have like a week and a half of free time. So what I will probably do in the next day or two is I'll put up a little survey of some topics I think would be good for us to cover or could be interesting. And then I'll just let people sort of vote on what their favorites are. So I know, I think Golan and I were talking about upscaling, like, what are the best upscalers to use? What are the different types of upscaling to use, that sort of thing. I realized we talk about animations. We also look at stuff like interpolations, interpolation models, like those sort of things. There's probably a ton of other things that I'm not really covering in this quote unquote intro class. So if there are things that you're aware of that you have seen other people do or want to play with, like we can do that, and like we can just also I'll leave a field in for just people to add their own ideas. Like one thing I want to cover sort of at some point is like a short little session on loading other people's workflows and how to manage like missing nodes, like all that sort of stuff. So I'll definitely cover that. What I would generally say is like anyone votes on anything, I'll cover at least a little video, like a little 20-minute video that I'll record either myself, if not a part of the class. So definitely if there's anything that you think I haven't covered yet that you want to cover, like please let me know. And I will get that survey up in the next day or two so people can sort of respond and I'll sort of see what we have. So next week we'll definitely have a little bit more animation stuff because it's hard to cram all the animation tools into 1 week. Because they do get quite complicated and you kind of have to describe a lot of different things and it's a lot of processing and waiting. But then we'll definitely cover some more stuff going forward. All right, so let's talk about animations this week. So when we talk about animation, like, I don't know, animation is such a massive category. It's like there are many different ways to do quote unquote animation. And even before ComfyUI and even before all these sort of like cool like animation models existed, people were doing animations using AI. So I just talk about like some of the techniques that we could look at. Like we won't look at them this week, but if anyone's interested in them, I've done a lot of them in the past. First, what I would describe is sort of like stop motion. This I did 2 or 3 years ago now. This is just using a control net and just like cranking on iterating images through it. So using that control net, the control net of OpenPose, getting to like sort of create different body movements. It almost has that sort of flickery. That's why I kind of call it the stop motion effect, where it's not really a smooth interpolate animation. It's really just, more of the journey images, but using control nets to sort of manage the the pose and that sort of thing. Certainly a technique you could do today, and you wouldn't even use the AnimateDiff, but you could do it. This would maybe bit of a pain in the ass in ComfyUI. You need to use a lot of batching, but we work pretty easily. Next is, oops, right here, image interpolation. So again, I mentioned that we might want to do a little session on interpolation. I would describe image interpolation as taking a image, like basically the pixel values, and interpolating into another image. This is a video I made in 2000 that is like 2000, 2020, and is like kind of the craziest version of this, which is basically taking 20 images and interpolate them and then stretching that into like an hour-long video. So you can kind of see like little pixels and things are moving. Image interpolation tools are really kind of like upscalers. They're like a hack more or less on interpolation. They generally look at structures, but they don't really know anything about what it's interpolating. So that's kind of the downside of them. But for a long while, this is what people were using is, if you ever see animations from maybe a year or two ago, where they kind of feel like they're sliding in and out of each other's like pixel space, that's sort of the image interpolation models. And we've kind of moved past those, but I still think there's something valuable and interesting in them. What we'll look at today are what I would kind of describe as latent interpolations. So again, this is going to be using like SD 1.5 in the AnimateDiff category. And we'll actually be able to interpolate between prompts. We'll be able to interpolate between latent images. We'll be kind of able to do a bunch of different stuff. But as is always the case with these things, like with SD 1.5, you have some funny images of, people riding dog, horses, and that sort of thing where the prompts get kind of screwy. But it's still fun to play with, and this is kind of what we'll look at mostly today. I think what most people are doing now is like mixing a bunch of these concepts together. This is a film I made a couple months ago now that really uses what I would describe as like a video-to-video technique. So it uses video. You then add a prompt over top of that video, and then you're also using interpolation to actually interpolate between some of these frames. You're using control nets to manage the outputs of those things. So there's a lot of different things you can do, and this is kind of maybe what we'll look at more next week, is how to like build up a bunch of this stuff. This is a good example of like where you can see that image interpolation where it kind of like moves and slides around. But anyway, this is sort of like where we'll kind of end next week with, and trying to tie a bunch of the various concepts together we've been learning over the past couple weeks. So there is one thing to think about when we talk about animation. Obviously, we've only been working with static images so far, and maybe we've batched and done a couple images, that sort of thing. But when we talk about some of the newer models, like the newer models, like SDXL or even like Flux One, which we looked at last week, like they can take a while to generate an image, maybe 10 seconds, maybe 8 seconds, maybe on an older GPU, like 20 seconds. And with animation, we're generating multiple images per second, right? So in general, maybe 24 to 30 frames per second is like a nice animation speed. You can get down to 12 or 8 if you want to make like a GIF or that sort of thing. But once you start to multiply making a single image times many, many images, you start to run into like this time concern, right? If I wanted to make 24 frames using some like SDXL on a medium, like that would take 10, 12 seconds. So to make 24 frames, we're now talking about 240 seconds, which is like 4 minutes of time. And if I want to iterate on the idea, I want to see how my prompt changes if I swap out a little prompt, or if I like, add a control net, like that adds more and more time. And the iteration cycles become really painful, right? If you're to try to do this on a Mac, it might take you an hour to generate like 2 seconds of footage because you don't really have the right GPU for it, right? So this is sort of one of the bigger concerns we have to think about when we think about animation. And obviously in a live class setting, it also becomes a pain in the ass. We don't want to wait forever and, wait 5 minutes, see if something generated correctly, find out I made an error, and then we do it again. It's just like annoying. But this is also a big concern for anyone doing these sort of tools like just by themselves, right? You want to wait 10 minutes to see what you made and then try again, like over and over. I'll also add less of an issue with something like Run Comfy because we have the ability to like pay a little bit more for a better GPU. A lot of folks work off local GPUs, and maybe they bought their GPU 2 years ago when, people were doing NFTs or any other like number of things, and AI was just like popping off, and you have a 12 gigabyte or 16 gigabyte GPU card. Like animations also take up a lot of VRAM, especially as you begin to add in like control nets and IP adapters and all that sort of stuff. So VRAM space also became a big issue for a lot of people when they were doing animations. So as I mentioned before, like a lot of the community still is stuck with SD 1.5. in part because of some of these GPU concerns, in part because of just tooling that exists, but also because I think like realistically, like, you know, if you're making a single image, the quality of that single image, like the fact that someone's gonna be staring at it and looking it over and maybe downloading it and then zooming into it, like quality of an individual frame matters a lot. But in animation, you kind of care more about the motion and getting good motion, or, you know, just being able to show a bunch of different scenes together. So that means the quality can be slightly lower as long as you get a good output of that motion. And that's kind of where something like SD 1.5 comes into play, right? We can generate somewhat lower res images. They look okay, but then if you put them in motion, like no one really cares. It's like pretty interesting to see it in motion. So a lot of people have sort of stuck with SD 1.5 as sort of their key. Sorry, for a second, I can tell Run Comfy is mad at me, so I'm gonna add some time here. So that's really the key, is like you kind of have to balance out your quality concerns with your speed concerns, all that sort of thing. There are also like this newer range of models coming out that are called LCMs. And what we're going to do today is we're actually going to look at an LCM model and use that. And I'll talk a little bit what LCM models are, but basically they allow us to do things a little bit faster, even faster than SD 1.5. So LCM stands for latent consistency model. I won't get into the details of that because I barely understand them myself. The main key point of a latent consistency model is that it allows us to generate images at a much lower step count. So by default in Run Comfy, you use the K sampler, you have 20 steps, right? And if you want to make a better image, you might crank that up to 30 or 40 or whatever. LCMs can generate images at 4 steps, 6 steps, 8 steps. And that means they can generate much, much faster in that case. The steps kind of take as long as they take, depending on your GPU. So 20 steps versus 4 steps, that should be a 20% less, 20% of the time it takes to generate that. So that's kind of why people are interested in LCMs as an animation tool. There are not many LCM models, surprisingly enough, partly because I don't think as many people are interested in animation using these tools just yet. There are many on our favorite website, Civitai. I promise you, I think this one doesn't look terrible. Okay, there's only a handful of somewhat suspicious images on here, but there are a number of models that are available through LCM on Civitai, and all you need to look for are the checkpoint tag. So this one's kind of interesting. Photon comes by default on Run Comfy, so this one is already sort of pre-installed for you. I'm actually gonna download one more and just sort of like show you how we would upload this. So I'm gonna grab the Delusions one here, and I'm just gonna download it. And we'll probably have to wait a little bit of time for this to download. These, because they are SD 1.5 models, in a sense, they're a little bit smaller. It's only 2 gigabytes. So, we're going to download 2 gigabytes of data, and we're going to upload 2 gigabytes of data to Run Comfy, which will not be the fastest, but at least I'll show you an example of what it looks like with a different model than Photon. But Photon, by default, does come installed on Run Comfy. So if you want to use that, you can, and that's this one. Okay. Thankfully, I had my mature settings turned on, so we don't have to see what these images are. The other thing to note is most of the LCM models will tell you sort of their preferred K sampler settings. So in this case, it says 4 steps and a CFG score of 1. I actually tend to prefer about 8 steps and a CFG of 2, but it says it works at that size. So again, like if you can use something at 4 steps and it looks good, that's pretty great. It's going to mean a huge reduction in the amount of time you need to spend to generate images. Let's see what else I have here for my notes. Yeah, so basically, when you look at an LCM model, hopefully it'll tell you sort of what its recommended step count are, maybe CFG score, as well as maybe what the other K-sampler properties are. So for example, I know for the scheduler, we'll actually use a thing called the LCM scheduler instead of like our traditional Euler or whatever scheduler. So we're going to use an LCM model, and then we'll generate a bunch of images, and we're going to use another model or another tool called AnimateDiff to actually animate it. This is probably the most popular node, I would think, for animation within ComfyUI. It tends to be the one that I see most people using. It works generally well across all of the different sort of types of animation you would need. There are other ones. There's one called Toon Crafter that's really meant for more like cartoons. There are other models that work specifically for different types of motion, but in general, this one's sort of like generalizable to work pretty well with a lot of tools. The good news is pretty much everything we need for this is already installed and run Comfy. For those of you that are running local, like you will kind of need to install all of these nodes as well as the models you need for AnimateDiff. But I just want to call out also this particular person, the person who made this ComfyUI model, also makes a bunch of other nodes that are also very good. So I think this is like generally a person to keep an eye on. And they also recommend different LCM tools. So you'll see they recommend Animate LCM. It supports a bunch of other models as well. There's a lot of decent good documentation here, which is fairly rare for ComfyUI nodes. So it's worth reading if you want to get really into this. I will definitely only cover like maybe 10% of what's here because there's a lot of tooling even around doing like audio reactive stuff. There's some really interesting tools that are available within this node, but I've only really dipped my toes into a lot of this stuff. The main thing I want to highlight here, and we'll come back to this again, is like this is how AnimateDiff quote unquote works. So AnimateDiff by default requires 16 frames of animation. So that's your minimum size for an animation you can have. And then what it does is does this sort of sliding window thing across all of your frames. So what we'll do is we'll batch generate a bunch of frames at increments of 16. It will then take those images that we provide it, and it will kind of interpolate between them. So you can kind of see here, this is basically doing a sliding window over all these images and kind of interpolating between those steps. And there's different things we can set in here to sort of determine the strength of the interpolation, whether it interpolates more toward the beginning of the image, toward the middle, toward at the end of it. There's a bunch of different things here. So you can kind of think about these as different sort of tools that are worth a read once you sort of have dug in more and played around a little bit more with how AnimateDiff works. There's a ton of settings here. I'm going to show you the most basic and like most common ones. But if you do want to get more into this, there's a ton of stuff here. And just like IP adapter, there was a whole rewrite of this library. But unlike IP adapter, this person kept both versions. So there's now what's called Gen 1 and Gen 2. The nice thing is if you open up any workflow that requires AnimateDiff, they generally still work. Whereas unlike IP adapter, you have to like rewrite a lot of stuff. So the good news is most of AnimateDiff still works these days, and I really haven't had any issues. If someone creates a node that like, or creates a workflow with an old node, it still shows up probably. Cool. So AnimateDiff largely works with SD 1.5. There are SDXL models, but they're all called beta, which means no one actually thinks that they're worth anything. There are also things called AnimateDiff LoRa's, and if you want to start to keep track of all the various LoRa's you need to use for all these tools, it gets pretty crazy. You can think about AnimateDiff as like, so the AnimateDiff models in general are like generalizable motion, right? How does a human walk? How does, I don't know, an airplane fly? Like more generalized big topics. But let's say you wanted an animation that was more like a snake wriggling through like sand or something. It's possible that AnimateDiff doesn't really understand or know how to make a snake wriggle. So in this case, you might train your own LoRa on an animation or like on a video of a snake wriggling, and then you would have a snake wriggling LoRa. And you would plug that into the model, and then would be able to generate those. Other ones people have like big like glass crashing or like explosions, like those sort of things. I won't cover that in this class unless people really want me to. Most people don't make animation LoRa's because they're kind of a pain in the ass. We're getting more and more niche as we go through this, right? Like lots of people make images, lots of people make image LoRa's, but as we get more into the animation field, there's less and less of these things. But there is a tool that I've used before to make LoRa's if anyone wants to train their own animation LoRa. But it's definitely getting further and further out there in terms of like how likely it is for it to work. Cool. Let's dig into generating animations then instead of run Comfy. So first thing I'm actually going to do is I'm going to show you how we might upload our LCM model. So as I mentioned, let's just go to the load default. Close up some of this stuff here. So by default, there is a checkpoint that uses LCM. So if you click on the checkpoint name, you just type in LCM, you'll see the only one it supports is an SD 1.5 called Photon LCM V10. I believe that's this one. This says version 1.0. Maybe this is version 1.0. just looks like V10. So let's assume this is this one. So this one is already preloaded, I think, on everybody's machines. Give me a thumbs up if that's true. If you don't see it, okay, cool. All right. So if you wanted to upload your another LCM model, what you would need to do is you would go over to your folders, you would go into ComfyUI, and you'll go to models, and then you'll go to checkpoints. And what I would do is I would probably create a new folder here, and I would just name it LCM. And then you can go ahead and upload your files to here. So upload delusions. I don't know. This might take all class for this to upload, but we'll see. Okay, cool. So this is now uploading. Once it's uploaded, then you should be able to get access to it. So we'll start with Photon just because that's probably what everyone has. Photon has a certain look to it, like I think a lot of these models do. It has a little bit more of like a sci-fi kind of look to it, which is maybe cool. But if you're looking for more realism stuff, there are realism LCM models that are probably a little bit better. You can also add LoRa's to LCMs. The key here being that your LoRa needs to be a 1.5 LoRa. So as long as you have a Stable Diffusion 1.5 LoRa, you can add that to a Stable Diffusion 1.5 LCM model, and it works pretty well. I think you could train your own custom LoRa on top of an LCM as well, but I don't know many places that support that. I'm sure someone out there has a repo that supports that. Maybe one of the big trainer systems has support for that, but I generally find that a regular SD 1.5 works as well. Cool. So let's talk about how we would actually generate animations. So the most basic version of this is we need to create basically a bunch of images, right? So what we could do is let's start by just generating our batches of images here. So we're going to use our defaults. We'll use the Photon LCM model here, and let's just generate a bunch of images. So I'm just going to let's say a bear running in a forest. We'll leave our negative prompt as that. And then because we're using the LCM model here, we want to change our K-sampler options. So as I mentioned, or at least as the repo mentions, you can get away with 4 steps. I think that's a little low. In my experience, you kind of get some fuzzy looking stuff. I would say 6 or 8 is probably better, which is still quite low. Next is CFG score. They say you can get away with 1.0. I've had much better results with 2.0. And the last thing we need to change is we need to change our sampler name to the LCM model. I think in almost every instance I've seen, if you use an LCM model, you need to use the LCM sampler. Sure, there's some scientific reason for that, but that's sort of what I've found. Scheduler, you can leave at, oh, this is interesting. I feel like I've seen people use exponential before, but I'm gonna leave it at normal. I think it works pretty well at normal. So what we're going to do here is we're going to generate a bunch of images. And the best way to generate a bunch of images is actually use our empty latent here and just change our batch size. So remember that by default, our AnimateDiff model requires 16 frames. So in order to get that, we're going to actually need a batch size of 16. So this would generate the minimum amount we can generate for an animation using AnimateDiff. So what I'm going to do now is I'm actually going to delete my save image node, and I'm actually going to create the preview image node. This way I can just see what my images are. I don't really want to save them. I just want to generate them. So now what we can do is we can run this, and it's going to generate 16 individual frames for us. It's going to take a little bit of time just to load our checkpoint. And we can already see this K-sampler is so much faster. Like we're generating 16 different images, and that took maybe a second. It was really, really fast. I hate this tray that comes with default with run comfy. So we can make this a little bit bigger. We can kind of see, okay, here's what our images look like. This is where I would also maybe play around before you start throwing this at an animation. Maybe here's where you actually want to see like, okay, can I really get away with 4 steps? See, I think those are a lot worse. So I'd kind of crank it back up to 6. Maybe we try 8. Yeah, I think 8 is pretty good. 8 is what I found to be pretty decent. We could play with CFG score. We could try to turn this down a little bit. That looks a little more naturalistic. Maybe that's good. We can leave that there. And a CFG score of 1, I think all should run faster. So, but now we've been able to sort of like quickly iterate and just sort of see like, okay, what are the right settings? So always do that before you start throwing stuff at animation, because then you're kind of like your variables are all over the place. So this way we kind of isolate the variables, we figure out what works well for us, and then we can sort of go from there. Okay, so next let's add in our animation module. So to do that, I'm actually just going to select all of these, and I'm going to give myself a little bit more space here. Oops, I always do this incorrectly in Run Comfy. Shift and drag. Okay, cool. So I'm going to give myself a little bit of space here. And we're going to use the AnimateDiff Gen 1. So we're going to type in AnimateDiff. And I want I think it's this one. Yeah, it's AnimateDiff Loader. You'll see it says ADE AnimateDiff Loader Gen 1. And that is sort of the easiest version to use. There's the Gen 2 isn't really any different. All it is like it breaks everything out into individual different nodes. So you have a little bit more control, but I actually find this one to be quite simple and easy to use. So we're going to start here. So as you'll notice, unlike say ControlNet or other tools that were operating on the conditioning chain, this one operates on the model chain. So what we're going to need to do is we're going to need to plug in our model. So our model out of our checkpoint into here, and then our model from our AnimateDiff loader into our K-sampler. So we're just kind of like plugging this in the middle of our model chain. Next, we need to select the model we're going to use. I always use it's this one. So it's SD1/MMSDV 1.5 V2. This tends to be the one I use. I have never seen anyone like really explain why you would need to use any other ones. There are also these other things that are called lightning models that allow you to even turn down the steps even further. I think these are generally meant to work with SD 1.5, and then you could use these and then you could actually have less steps. So this is sort of like in contrast, or like to use instead of the LCM models. Again, your mileage may vary. You can play around and sort of see what works best for you. But I'm going to use the MMSD V1.5 V2. And then I set the beta schedule to auto select. I believe the answer is you usually want to use square root linear for AnimateDiff or LCM. But if you set it to auto select, it does it for you, and that seems easier to me. There are two other things we want to do here, which is we need to use like the grays are always sort of optional stuff. You'll see here, this is where you could add, if you had a motion LoRa, you could add a motion LoRa here. And this would be an AnimateDiff LoRa. And there are some here. So you'll see that some come pre-installed. So there's one that's like pan left, pan right. These are more like camera motions. So say you wanted something that was more of a zoom in motion, like then you could add in these sort of things. So I kind of see these as like very specific types of motion or very specific movements that you could then add in addition to sort of your animation, and have some like fine grained control here. So this is kind of where you can add in different sort of motion stuff. I don't really need this, so I'm going to delete it. The one thing we do need is we want to use our context options. So I'm just going to shift, control, drag out, and then unselect. And you'll see there are sort of a couple different options here. There's a standard static, standard uniform, looped uniform, views only, batched. I've only ever used standard uniform and looped uniform. And most of the tutorials that I've found in the past use looped uniform. You would think this means by default it loops, but it doesn't really work like that. I don't know why. It's probably some other reason why it's called looped. And there is a way to set looping here. But I have to tell you, every time I've tried to use it, it looks like crap. It does not loop at all. So I leave it to false. The key thing about this is if we remember like the little stride animations here, this is what we're able to get away with now. Is so if we go down to looped uniform, yeah, okay, so this is what it is. It works differently in that it loops back upon itself to do the interpolations. So different versions of these will give you different stepping systems. So looped one kind of loops back on itself a little bit. You can read about what each of these steps requires, or what each of these little inputs does. I'll tell you the most common ones that I play with are the context length and the context stride and the context overlap. The overlap, so basically context stride is how many images to look at one time. So by default, it's 16. I've rarely ever moved it higher than that. And I find it's hit or miss whether or not it works. Your stride is, let's just read over here. So the stride is the distance between all latents. So basically, if you made this to 2, it would actually like jump a frame and actually be a little bit longer. Um, and then the overlap is how many of these overlapping like sort of windows should it look like at once? Basically, if you make the overlap larger, you should have a smoother motion between your 2 frames. Should being the operative word. It doesn't always work like that. And if you make it too high, it just kind of like blends. It does like a frame blending rather than like an actual animation blending. If you make it too small, like and we can actually play with this and look at it. If you make this to like 1, it basically just does like a cut. So rather than actually animating, it just like cuts between the 2 images. I think I set anything else below here much different. Yeah, we'll leave this as is. The other thing we want to add is we want to pull in our sample settings. So I'll do the same thing, Control Shift unclick and use sample settings. This kind of determines, again, a lot of the noise and sort of the interpolations between these. The only thing that I know that pretty much everyone changes is the noise type. Most people change this to free noise or empty. Again, I assume this just changes a little bit of how the noise works between this. We could play with this and sort of see if we can figure out what it actually does. It's probably like very subtle differences, I imagine. And then I think we can leave everything else as is. So the Gen 2 version of this just breaks out every one of these in every one of these steps sort of into their own node that you then have a little bit more fine-grained control over. But in general, like this works fine. So at this point, we can now finally generate our animation. We're feeding in our 16 images into our model, and then it's figuring out how to basically animate between all of these. Now, the other thing we want to do is we actually want to look at our animation as an animation, right? If we were to just do this, we're probably only going to get our individual images. So for this, we want to include a video combine node. So it's this one. It's from this node library called VHS, Video Helper Suite. This tends to be the easiest thing to quickly generate animations. It kind of throws everything into an FFmpeg output, which is nice. But you can sort of play with your settings here a little bit. So what we'll also do is we'll drag out our output from our VAE decode into Video Combine. You can also add audio. You can do like all sorts of this. Basically is a video maker. Since we're only generating 16 images or 16 frames right now, I think leaving the frame rate at 8 is probably the best. It's going to give us a 2-second animation. It'll be very choppy. It'll be very GIF looking. And then we can choose to save it or not. So usually what I will do is I'll turn save output off for now, generate some things, make sure I like where it's going, and then I might start saving it. Run Comfy, again, I don't think really has a file limit, so you can kind of just do whatever you want to do. But in my experience, it's just better not throw a bunch of crap in my folders that I have to then figure out what's there from there. Loop count, we don't really need this to loop. It automatically loops in the previewer. This is only if you wanted your output file to loop. Sorry, let's see, there's a bunch of stuff going in the chat. So let me just make sure I'm there. Whoops. Oh, yeah, so Golan, so these frames are not ordered. The output frames that we'll get from this, once we throw AnimateDiff into it, then it is ordered. So this is just sort of like batch generating a bunch of images. This model will sort of like make them consistent.
Is there a limit to the number of images you can ask for in a batch size? Like you said 16, but could I put 1,000?
You could. So this is where it's a little unclear to me. Usually when you ask for batches on a GPU system, it actually throws all of them onto the GPU at once. In which case, if you ask for 1,000, it might just like crap out for you. But it's also entirely possible that like Comfy is doing a smart thing and batching at one at a time to the GPU and then pulling things back when it's got it. So we can try it and just see if we can break it. I will say if you set this to 1,000, it's just going to run for probably like 30 minutes. It's going to take a while to run. But I don't see why you couldn't do that. Like we'll look at, turning up to like 96 or something in this session just to make a slightly longer video.
And to clarify what AnimateDiff actually is, then it's basically a network that's been trained on how things move. And so it understands natural motion of common things like people walking or animals running or cars driving around and things like that, plus some camera movements. And then the motion LoRa's, animation LoRa's, are sort of fine-tunements for how things could conceivably wriggle or move or slide or whatnot.
Yeah, exactly. I mean, it's just like images, right? An image model is generalized data, right? But there might not be there's something specific that you want to train on, or like you just want to like gravitate toward. That's where LoRa would step in. And the same thing is true here. Generalized motion, it probably understands to some degree, but it is all trained on basic camera movements or like camera ideas, right? So like, something popping up in the water means the camera might follow it. So therefore it's kind of stays static, right? But yes, and then LoRa's are sort of like fine-tuned, like I want this exact motion. And here's a bunch of data that supports what that motion looks like, so you can build off that. Okay, cool. And Sean, so the reason I haven't hit a limit for uploads is because I'm on the pro account. Sean's saying there's a 10 gigabyte for free account and 200 gigabyte for pro. So if you're uploading a lot of models, you might be hitting your free account limit, would be my guess. So be aware of that if you are uploading models, because that will quickly chew through that gigabyte amount. Thank God that they added their own Flux model, so you need to upload your own Flux models. That would be most of your file management there already. Oh yeah, and Garrett, sorry, I forgot to mention this. For AnimateDiff, you need not only the nodes, but you also need the models themselves. And I did record a video earlier today, like an hour ago, on getting the right models, because you need to download all of these models as well in order to run any of these. And basically, you just need at least one of them to be able to access it. And those go in yes, where you put it, models, AnimateDiff _ models. Cool. Okay, let's hit play on this and see what we get. What happened here? There we go. Okay, cool. It's moving very slowly. I don't think that's right. I think it's just, I might switch this to a video file. There we go. Okay. Yeah, once you switch to a video file, you get all the FFmpeg commands around CRF and pixel format and that sort of thing. This is looking more like a bear dancing or a bear human walking in the woods. This is a really common problem, which is like, again, what is AnimateDiff been trained on? Probably people. So by asking for a bear trying to run in a forest, you're probably getting more of a person movement running in a forest. And again, if I were to run this again, and this should use different randomization settings, so I should get a different randomization here. Or different seed settings. I should get a different output look and feel. Yeah. Let's also try putting the LCM score back up to 2. I feel like I'm getting some like looking very neurally. I want something that's a little bit more realistic. Because video combined, I think, is actually running FFmpeg behind the scenes, it's probably a little slow. Man, these almost look worse. Maybe I'll go back to 1. And try lowering. Maybe let's bring our steps back up a little bit. Yeah, that's an interesting question, Golan. The thing with steps is they kind of always they determine both, right? They determine both the output as well as the movement itself. I don't think that the steps really affect movement as much as the output of the images. Um, so it's possible that we could play with these and see if we could get different results. This again, where prompting matters a lot, right? I've got a pretty like crappy prompt right now. Like I could try making this like high quality photo.
Yeah, I was wondering
Okay.
whether steps, applies to the image or the movement, because having a really low fidelity image of like interesting abstract blobs could
Yeah.
be really compelling if it is like really moving like a person with a limp, or something.
Yeah, that's where prompting is going to be important, right? If you prompt a like weird little, blobby shape, but you ask like, but the motion is using maybe a motion lure as that's someone walking or something like, then you could get better results of this. See, like already adding in a little bit more of a prompt, I get a slightly better output. I think some of this is also the photon model itself. Like photon loves these sort of like purples and greens. Um, so some of this is like tied to the model, some of this is tied to the prompting. We're gonna look at like throughout the rest of our session today is like adding in new layers of all the stuff we already know about, like control nets and other things, to actually make a lot of this like more interesting than just sort of these like I would describe these at best as cinemagraphs, right? They do a little bit of motion like in kind of a slightly compelling way, but like not in like this is someone walking, this is not like a film sort of shot, it just does a little bit of motion that's kind of interesting. We could try something here. We could try making this a bit longer. So if we want to make this longer, the best way to make it longer would be to change our batch size. Yeah, and I'm wondering what that is. I think that might be this AnimateDiff. Like we could try a different model output here. Like we could try something like and we could try improve 3D motion, improve 3D V1. Or we could try maybe one of these, let's try animate diff motion. I don't know. See what these do. Okay, so what I was also going to say is that if you want to make it longer, right? So right now it's 1 second, or it's actually more 2 seconds. It's but 16 frames broken down at 8 frames per second. If we want to make it longer, what we would generally want to do is we want to make this 32 frames. This is going to make it twice as long. If we want to make it 3 times as long, we make it 48 frames. Let's just leave it at 48 frames. See if we get better results here. Good, sorry. And this may also be a case where what we really want to do is we want to go back and just use, if you really don't like the output of the images, you could always go back to your default 1.5 and make sure you change all of your K-sampler settings, right? So we go back to 20 and a CFG score of like 7 or 8, changes back to Euler. All it's going to happen is going to take a little bit longer to run, but maybe that's okay. So it's kind of up to us how we want to sort of see this work. I'm going to still work off LCM just because it'll be a little bit faster for me. And for demoing purposes, it'll probably be a little bit easier. But I would say in general, there is a loss of quality when you switch to an LCM model. It's a big burly bear. So now I believe we're getting a longer video. Maybe not. Let me hit this one more time. Make sure I didn't mess up my steps here. Okay. So you'll see the K sampler is basically linear, right? You add three times as many frames. It's going to take three times as long to make this operate. But you'll see this is basically an interpolation model, right? It doesn't really know motion in the sense of like a bear should always be moving toward the camera, right? Basically, all it's doing is taking a bunch of those images, those sort of interpolation frames, and find the most logical way to interpolate the motion, right? So we kind of have this scene where like, I don't know, he starts walking on his back legs and he shrinks backwards. This is where, if we're not really happy with how much motion is really happening here, this might be a way for us to, we should change the model. We could change our model back to like more of a stabilized motion. There's these stabilized motion models, The other thing you would play with is your context overlap. Context overlap should give you a little bit more strength between the two frames. So right now it's saying force. It's basically like, here's one frame, and then it's saying like quarters of each side and kind of figuring out the math between those. If we made this something like 8, we might get a little bit more of a smoother motion, but we might also get more of almost like frame blending rather than the actual motion. And because we're using SD 1.5, so much of this is dependent on the seed you get. Like different seeds will produce really good looking bears and other seeds will produce really poor looking bears. This is maybe where like you would want to throw on a LoRa, right? You have a LoRa that's trained on bears. You really want to output bears. Now you can get better bears by using a LoRa on top of everything. The nice thing is because it is to SD 1.5, we could use IP adapters. We could use LoRa's. We could use control nets. We can layer on a bunch of different things here to produce like much better results. So you can see here with a stabilized motion model, the bear isn't moving around as much. And also probably because I changed my context overlap, there's a lot less sort of like big motion between these images. This sort of just feels like it's on a windy day or something, and the bear is kind of just standing there. Let's do one last one where I go back to my original model. So the context length, so Doug had a question here of should the context length match the batch size of making the video longer? No, because what's actually happening here is our context length is choosing how many frames we're looking at one time. So even though we're making an animation that is 48 frames, we're saying only break that up into 16 frame chunks when we do the animation. If we made this longer, I think we would generate less, it would generate the same amount of frames. We would look at a wider range of our video. Again, I feel like so much of this is worth just playing around with and sort of seeing what results you get when you change different numbers. This one's actually not that bad. I mean, the bear is moving like backwards and forwards, which is a common problem in these motion models. This is where you might want to throw in a LoRa that's a zoom in model, right? So it's like zoom in as the bear runs, probably the best way to manage this. But fidelity wise, looks pretty decent. It's clearly a bear in snow or bear in water, and it's getting little splashes and stuff. All right, so what we're gonna do, let's take a little break. And then what we'll do is we'll come back and we'll actually begin to layer in different ways to change our motion. Do you have any quick animations for prompts for animation? Yes, this is a great question. I don't know. This again is like a question of like, does AnimateDiff manage the prompting, or does the original checkpoint manage the sort of animation settings? I've yet to see anyone that actually has done like a breakout of like what prompts work well in AnimateDiff. I can tell you running works pretty well. And okay, so Sean, you're noticing better results with free noise and empty. So switch this to empty and see if we get better results. So again, I'll run a couple more of these while we're at break, and we can just sort of look at them. The other thing I should also mention is a kind of a nice thing is if you want to save this like video, even though we're not saving the file, if you just want to like look at this and compare this to another one, you can just copy this. And if this just like has nothing attached to it, it will basically just like live on forever as sort of a zombie GIF. So you can just sort of run this again and you can sort of compare the two. Now, obviously, our seeds are being regenerated every time we run this. So if I wanted to get really like deep in the weeds on variable, like, shifting and that sort of thing, I probably want to like fix my seeds, then make a couple different copies and like compare that way. This is again a place where like I personally feel like Auto 1111 is better for sort of outputting these sort of like batch ideas of like, okay, show me this much motion, show me this much motion. Like if I crank up the weights of these things, that sort of thing, I should get better results. Interesting. I get very different results with empty. Now we have a bear that's kind of dancing and then Get a lot of dancing bears. All right. Well, let's take a break now, and when we come back, we'll start to build up upon this and look at different ways to sort of make this a little bit more exciting or a little bit more interesting in terms of animation. So let's come back in like 10 minutes. So we'll come back at like 9:05 for those on the East Coast, 5 after for anybody else. Yeah, so we'll come back in a little bit. All right, bye. Okay, so during the break, I tried to make some bears using the base SD 1.5 default model. So what you see here is you've got that photon LCM model in the middle. You've got the sort of base SD 1.5 both here and here. And I just loaded in the that other LCM model I was playing with, the Delusions one. So Delusions one definitely has a look to it. Definitely more surrealist kind of thing. Maybe more animation kind of looking. So you can run, these with the base 1.5 model. I'll say it felt like it took like 3 times as long, because it did with the number of steps that I was adding. So it does, again, it does sort of add to it. And I would say even like the look of this, there's a little more flickering going on with it, probably just because it's got more of a high fidelity look to it. So some of that is showing up there. Again, prompting could change this. We could add IP adapters or LoRa's on top of this, probably make it a little bit cleaner. We could play with the context window to make these animations a little less weird and freaky. There's things we could do, but you can start to see like you can, if you choose, like you really like the look of SD 1.5 or whatever, you could run it and still generate animations using it. You're just going to wait a little bit longer. Okay, so let's pick up from here. So these animations, as I mentioned, are like fine. They're like, they kind of look like they're cinemagraphs. They're not really doing a lot of motion. There's kind of some interesting things we could begin to play with, though, with the idea of being able to animate our prompts. What if we wanted to animate actually changing our prompt? We actually wanted to go from, a bear in a forest to a bear in a city to, a bear on the beach or something, right? Like this is kind of where this tool gets more interesting in the sense of it's not just trying to replicate motion it's seen before, but also trying to integrate new concepts or new prompts into it. So let's take a look at doing that. So we're going to do that with this thing called the batch prompt scheduler. Um, and if you look up prompt schedule, I've done this before. If you look up prompt schedule, you'll see there are about 30 different prompt schedules. The one that we want is the one called batch prompt scheduler. It is this one. It is the batch prompt scheduler that is not SDXL, that is not scale. It is just the regular old batch prompt schedule. So we're going to drag that in. We're going to drop this here. And you'll see when we look into this that we basically want to replace our positive prompt with this thing. So what I'm going to do is I'm just going to outright delete our positive prompts. I'm going to drag my clip from my original model into the clip of the batch prompt scheduler. And then I'm going to drag the positive node out of my batch prompt scheduler into the positive of my case sampler. So if we look at our little text field here, we'll see that we have a string with a number and then a blank string with the thing with like basically a blank string. So what we can do here is we can actually say, I'm going to clean this up. Remember that we have 48 frames, right? We've got this set to 48. And we have a bunch of settings here to say like, hey, at every one of these steps, do with like, here's my prompt, right? So I'm going to start with a prompt that says a man running in a forest. And I'll just add in all the little crappy little prompt things we need, high quality 4K. So I want to make sort of like a looping video. So what I'm going to do is I'm actually going to copy this as the first prompt and as the last prompt. The idea being here that, hey, we should be able to cycle back around this, right? So let's then think about what we want to do next. So remember that this is sort of working at every 16 frames. So we want to do is say at the 16th frame, which in this case is 15 because it's zero-based indexes, we want our man running to be running somewhere else. So let's say a man running on a beach, ocean waves, keep that there. Then we'll say let's say at 32. So we'll say at 31. We want our man running in a cyberpunk forest, cyberpunk city, street lights, skyscrapers. And we'll remove this. So what we're saying now is we've got At our first frame, we should expect to see a man running in a forest. Then the man should change to being on a beach. Then the man should change to being in a city, and then should go back to a forest. So let's go ahead and run this and see what we get. I'm going to clean up this stuff a little bit. And I'm going to switch back to my photon model. I think the photon one's going to look better for this. Okay, so let's go ahead and run this now. So we've got our man on the beach, a man running in a forest or beach. We didn't really get our cyberpunk city. I've run this so many times. This sort of more or less the same prompt. Cities are always the hardest thing for this thing to generate, and I have no idea why, because the whole look of this thing is very cyberpunk. Let me think about what I could do here. I mean, it might just be regenerating it with a different frame count or with a different seed and seeing if that works better. I also feel like we're getting really easy looking stuff. Let's try doing this with just a 1.0. Try this one more time. Yeah, that's pretty cool. Now, you can kind of see that our problem here is that this model really has no idea of like where the runner is directed, right? Like we're just saying the person's running in space. And each one of the frames that we're kind of generating is generating, sometimes they're facing backwards, sometimes they're facing forwards, sometimes they're facing to one side, or they're facing at like a 3/4 view. This is kind of the challenge of prompting. We can't give clear direction. Because SD 1.5, I can tell you we can try to say like facing forwards, but it's not necessarily always going to know that. We could get different results out of this by playing with it and trying to prompt our way to this. Oh, yes, thank you. Sorry. Yes, Tika, I will share this. Let me share this workflow. Batch. Animate diff flow. I'm just going to share it in our chat for now, and I'll upload it to our workflows folder once we're done. There you go. And actually, really quickly, let me remove this and turn it back to a regular encoder, just so I've got that one as well. So let me just say, man on the beach. Okay, so let me save this one as well. Called animate diff basic flow. And does undo work on this? It might. Cool. Okay, great. Perfect. So now we've got like a basic skeleton of what we want to do here, right? What else could we be doing that would make this better? Well, I can tell you already, like if I've got a guy running, probably the best thing I can do is like actually hook this up to a control net, right? If I know the exact direction that I want someone running, like probably it's going to be easier for me to actually find a video of someone running and begin to connect that to this whole system. So let's take a look at how to do that. So first off, we need to find a video of someone running. So I don't know, we can just go to the internet and hope we can find something here. So let's say runner video square. This is not going to work. Let's go to Pexels and see if we can find anything. Pexels video. Let's see, runner square. This is pretty good. We've got a video of a guy running here. I bet you could crop this to square fairly easily. I'm only going to show cropping to square because I know it's a pain in the ass to do tiling with control nets. So, well, actually, probably won't be that hard. Let's try it. Okay, so let's go ahead and just download this guy running. Basically, what we want to do is we want to take his skeleton of him running and just replace it with our prompt, right? So we'll use a control net for that. So let's go ahead and download this. I've already downloaded this video before. Clearly, this is my go-to prompt, my go-to tutorial. Let's see if there's any other videos of someone running here that might be interesting. This one's kind of interesting. I like the background of this too. Plus, it gives us this like zooming motion. So we could try this too. All right, let's try this as well. Okay, so let's go back to Run Comfy here and let's think about how we were actually going to integrate our control net. So we know we're going to need a control net. We're going to do that. So let's just grab and create a little space here for ourselves. And so from last week, we know what we need is we need a control net. And I think we want advanced. Okay, so this works on the conditioning pipeline. So we need to do then is we're going to take our positive prompt from our batch scheduler, plug that in here, take our positive and plug it into the case sampler. And then we'll need to do our negative to negative, negative to negative. And we are control net. So I'm just going to click on our little node here and go shift control. And it's going to be load control net model. And I can't remember if I need the advanced or not. Let's just load the advanced one. I don't even think I need that. Let's try the other one. Yeah, let's just use this. Okay, cool. And we know we are going to want the SD1.5. And we'll use the open pose control net. And now we need to feed in our video. So how do we feed in a video if what we really actually want to feed in our series of frames? So the best way to do this is to use a node that we haven't yet looked at, but it's called load video. And there's sort of two different options here. We've got load video from URL or load video upload or load video path. Again, if you have a URL that you just want to feed it directly, you can do that. I think load video upload is the easiest one to use. Yep, there's my guy. And what I'm going to do instead is I'm going to upload that new video. So we'll choose video to upload. We'll select this video. We'll hit open. So the load video, let's just take a look at this by itself. The load video node has an output of image as well as some other stuff that we don't really need to worry about. So let's talk about the forcing of, basically we have a very, very large video. I think this video is something like, well, it looks like it's 1080 by 1920. We want to actually crop it to square just for our own sanity, because our output's square, and we know control nets get a little wonky if you kind of try to mess up different dimensions. So the other thing we've got here are the cap of the number of frames we want to load. So I know my output is only 48 frames. So for my own sanity, let's not load in any more video than we need to. So in this case, we're going to load in 48 frames. You've got some other options here, which we might look at more next week. One thing we could do is we could load in like 96 frames and just do every other frame. That would give us more motion. And then we could do like interpolations after the fact. We'll talk about that more next week. So let's just leave it for now at a frame cap of 48 and a select every nth by this. There's also this force size feature, which I think might be nice for us to use because we know we need to get our eventual dimensions into 512 by 512. So let's click on this and see what our options are. You'll see we've got sort of these options of like, what happens? So like, what happens if we just set 512 by 512? Is it going to squish everything? We can kind of choose it and then look. So the nice thing about this is what we could do is we could take this to an image preview. So we add a preview image node. We take our image and just dump it here. Now, the problem is because of Comfy's workflows, everything's going to run all at once. So it'll still regenerate our animation. But this way, we can at least, before we run and throw a control net at this thing, we can just sort of see what our output here looks like. And actually know, let's have this bypass. So we're going to bypass this node for now. So to do this, you just right click on your node and you just say bypass. They're just going to skip the control net for now. It's going to generate our new animation, but we won't get an error when it says like, hey, I don't have any images for you to pass me. So let's run this and let's just see what happens to our images when we run this. I think it's going to squish them, but let's just sort of see what happens. Yeah, as I expected, I think it squishes it. Okay. So what we instead need to do is we're going to take our output here and we're going to set it to an output of, this is always the other question is like, is it width by height or is it height by width? I think it's height by width. Let's just see. So this will now make our image. And you know what else I'm going to do? I'm going to bypass all of this. I'm just going to select all of these and bypass them all. This will hopefully not output anything, but it might also throw an error. So we'll see. So this will give us just the width dimension of 512 by 512. Let's go ahead and cue this. Okay, well, when in doubt, we can just set our custom width to be forced to 512. There we go. Okay. And then what we want to do is we want to feed it to a image crop system. So I believe it's image crop. And we want to go, it's crop. Image crop location. Oh, which crop tool is it? I never remember. It's this one, image crop plus plus. Okay. So we want our images to be 512 by 512. We're going to crop from the center. And let's just make sure this works the way we expect it to. Cool. Now, the other thing I'm noticing here is that this video starts from a little bit further back than I would like it to. So what we could also do is we could skip a handful of our first frames, right? So let's say we skip the first, like, let's say we skip the first 30 frames. And this will hopefully give me just more of the center image, actually, maybe even a little bit more. think this is 30 frames per second video. So we'll just see if we can get a little bit more of the larger size of our body here. Image previewer always takes forever to upload when it's got a big batch. Okay, let's assume that worked the way we want it to. What we now need to do is we need to pre-process our video. We need to process these images into OpenPose and then feed that OpenPose into our control net. So at this point, we can unbypass our control net. We can then feed our images into a, this is the OpenPose pose processor. So there's two of these. There's this OpenPose preprocessor provider. There's OpenPose pose. I think they're more or less the same thing. So we can take this into here, and we want to feed our batch of images into OpenPose. And then we want to, let's disable hands, save ourselves a little bit of time, and disable face. And we'll keep the resolution at 512. And now this is, yes, this is correct. Okay. Because I remember we need to use the advanced one so we can do batching. I don't know why the normal one doesn't do batches, but this is the one we do. Okay, so now what we're doing is we're taking our video, we're turning it into frames, we're cropping it to the correct dimensions, we're feeding it to OpenPose. And if we wanted to preview what our OpenPose looked like, we could do preview image here. So let's run all of this. Just make sure this works before I get an error. Cool. So now we see that we are getting our pose detection system here. You know what? I want to move a little bit further into this video. I'm going to move another second in, just see if we can get a little bit bigger body here. Okay. Yeah, a little bit bigger body. That works. Cool. So now we can feed our control net into our sampler system. And hopefully that means that our output guy here now it maintains a little bit more of a consistent pose. So we'll unbypass all of these. I don't really need it to show me every image. So let's just generate our video and make sure that works. We'll hit Q prompt. Error message, control type, control net may not be supported for sliding window context. Make sure to use ComfyUI advanced control net. I thought that's the one that I was using. Let's see. Control, oops. Ah, here we go. So we need to use the ones that are labeled ACN because, of course, they're all labeled advanced control net. So why would it matter? We need to use the apply advanced control net using the ACN tag. A very classic problem we have with everything in Comfy. Okay, so we're going to replace this with this thing here. And we want, so we're going to do positive to positive. positive to positive. I have literally done this, like, I think every time I do this, I make the exact same mistake. Negative. And then we need our control net. So we're going to, I'm just going to drag this out, see what it recommends. We'll do a load control net model. And this one. And we'll use, again, we'll use the open pose setup here. And then we need to feed our images into this model. I think that's everything we need. Model optional, V optional. Yeah, I think that's everything we need. Cool. Let's try this again. There you go. So we can start to see the power of Comfy, because this would be a huge pain in the ass to try to do using any other tool. But because we can actually like combine things in a really interesting way, we've got the ability to actually manage and manipulate manipulate our motion using a better tool, right? Like, let's be real, like those other motion tool, the AnimateDiff motion looks kind of shitty. But in reality, because we've got the AnimateDiff motion doing our sort of like prompt changes, we can use the control net to actually manage the body position. And that's a little bit easier, and that's going to give us a better, more consistent looking result. Now I can see here, even the very last frame, it sort of like zooms back to the very end. We could probably swap out the looped system here for maybe something that's not looped. Let's try this again. Let me do context options. Let's do standard uniform. 16.1.1.1. I think this is everything we need to do. So we could try this. This should give us a little bit of a better end result. Yeah, didn't get that like weird warp back at the very end. So let's talk a little bit more about just some quality of life stuff, because this is going to happen as we begin to build up more and more of these workflows. We've got kind of an insane spaghetti thing going on here, right? Where we've got our control net, we've got an AnimateDiff, we've got all of our other setups here. So this is where usually people will include stuff like groups. So to add a group, you just right click onto the screen and say add group. And then you're giving this a title, so you could call it prompts. And then anything inside of anything touching the prompt group is going to give it that name. So let's just make it a little bit bigger. So drag this in here, we'll call it prompts. Then we can move the group around, which is kind of nice. Gives you a little bit more of a cleaner way to move things around. Let's make another group for AnimateDiff setup. So we'll call it AnimateDiff. And we can color this as well if we want to. Can't we? We change the color of this thing. Edit group. Color. Can make that one yellow. Drag this one out. And then we move all of our AnimateDiff nodes into here. And then we've got our control net. And what I might do here is I might just break these down into a couple different pieces. Now that I also know this works, I can probably like delete all my previews. It kind of just adds a bunch of crap to the screen that I don't really need to see. It's easy enough to add them back in if I want them later. So let's just stack this. Or like there's different ways to do this. Everyone has their own management flow. Like you might want to do like a right to left thing here, like to sort of show these are together, but they're stacked. Let's add a node here, or not a node, sorry, let's add a group here and call it open pose. And of course, that works is a little annoying. Drag in all of our video, all of our nodes here. It's like Velcro. Can edit our group. That green. And then we can add another one over here. We can call this open pose control net. You could even have groups within groups. I think. Nope, you can't do that. Interesting. But you could. Put our case sampler out. Make this kind of cleaned up a little bit, stack it. And then if you wanted to, you could also make stuff for the case sampler, the V decode, that sort of thing. The thing that's kind of helpful also is you can add little notes. There is a note node here. So maybe you want to say, you know, make sure video can be cropped to square in this instance. Let's talk about some other nice things that could happen here. One of the things you'll notice is basically if I want to change the length of my animation, maybe I want to double this to like 96 frames. Right now I have to do this annoying thing where I have to remember to also update my frame cap, right? So what I can do instead is I can actually convert both of these values to like an input. So to do that, let's go to the empty latent image. Let's click on it and we'll go to, we want to go to convert widget to input. And we're going to say convert batch size to input. So now my batch size and input, I'm going to go over here to load video and I'm going to do the exact same thing. I'm going to say convert widget to input and I'm going to say convert frame load cap to input. And what I'm going to do is I'm going to come over here and I'm going to make an integer, primitive integer. And I'm going to connect that to both the batch size as well as my frame load cap. And now I can just set this to be whatever I want. So I could set to 96. And now it would automate, making sure that I had all the right amount of frames. Because if you don't do that, you will get an error message or like basically when the control net stops working, you'll just get gobbledygook afterward. So this is kind of a nice thing again, like as you begin to build up workflows, you'll want to be like, oh, I've got some variables I want to make. So this is the way of making essentially a variable you can control in one place that then works downstream. Okay. So at this point, we can also now finally like turn on our saving our output here. The other thing that's nice about this is the VHS node also includes the save metadata tag. So now you can not only like save out this workflow as some workflow, when you save out the video, you can also then drag the video back into Comfy and it's going to also load in your workflow that way as well. It's kind of cool how you can just like basically pass around video files that essentially are then also workflows. For my own sanity, I'm also going to use this right now. I'm going to do, let's say, call it AnimateDiff control net flow. And let's run this one last time so we can save out our video. And I guess I am making a longer video now. Now I am making a 96-second video or 96 frame video. Because I'm doing a lot more frames, I think it would have cached the initial. So why is oof that got Well, let me just stop this real quick. History. Yeah. Something happened here where this got set, like by accident, this got set to be way, way high. And it crashed my system because I was trying to load in an OpenPose set up at like 12,000 pixels. Let's try this again. Where did it find the token error? Okay, well, let's try this again. So unfortunately, because I crashed my GPU with VRAM, I tried to do too much VRAM. It's got to reload everything now. It's going to take a minute.
Derek, quick question once loading.
Yeah, of
Um,
course.
so now you have some sort of temporal coherence because of the control net, but in the background you still have a morph, a basic morph,
Yeah.
which follows the prompts. I was wondering if you have any experience with GigaGAN or StyleGAN-T, the kind of GAN-based prompt-based systems.
I do. I mean, the downside of those tools is that the models themselves are not really as good for prompting, right? Like StyleGAN wasn't really meant to be a prompting tool. So even though someone sort of bolted on a prompter on top of it, the models themselves are not really meant to be sort of this big morphing system. So you could essentially, I actually wonder if GigaGAN is. I wonder if someone has. I bet someone has like a comfy node for GigaGAN. See if there's a StyleGAN T1. Someone has comfy support for StyleGAN too. Yeah, so I mean, I would assume it would be fairly easy to sort of bolt on one of those models if you wanted to. Was
I
that
see.
your
I was
question?
just one. Yeah. Do you see any advantage why someone would go about using those systems?
Your morph would be a lot cleaner, right? Like interpolations in a GAN are very, very
Mhm.
clean because they're basically using a latent space interpolation. And you're
Yeah.
maybe using the morph the text prompt to sort of find the right latent space. That would be the only reason, but I would say like there's probably a better way to even clean up this morph. Like one thing
Mhm.
we could look at in future weeks is using IP adapters to actually encourage different types of images as the background setup. So like you could even maybe get a better morph out of that as well. This is also where maybe something like playing around with the AnimateDiff settings to change the context overlap. Like I bet if we made this larger, did this finish? Looks like it finished. But if we made this larger, I'm gonna turn our length down here a little bit again, so it's runs faster. Oh, the other thing I made a mistake here is if I set this to 96, my prompt was not changed to match that length. There's really no way to automate this, I don't think. I don't think there's any way for me to basically have this scheduler flex to the length of my prompts. There probably could be a way to do that, but it's not like out of the box native for this. So that's gonna be annoying. But anyway, that's like just a thing to know about. But I bet if I set my context window to be a little bit wider, I might get a better morph here in the background.
I see.
I would also hope that, now that Flux seems to be everyone's, favorite toy, that we might get AnimateDiff stuff for Flux, but who knows? That's not happening yet. Control nets are already out for Flux 1, at least a couple. So we'll see if we get newer versions with these bigger models, because with the bigger model, it's probably gonna do a better job of morphing between these shapes as well. Yeah, like we get it gets his arms raised up now when we get a little bit later into the video. So I mean, I should say I grab this from Pexels, but there's no reason that you couldn't with a friend, also go out and just record an iPhone video of you doing the same thing, right? Like, you know, the exact motion you want, go record it and then bring it into here. We really get into basic puppetry now with these tools. You can do whatever you want with your own body, and then you can use prompting to sort of stylize it in the way you want it to look. Yeah, I don't know if that actually made this animation any better. There's that hard cut there that I don't know. That's so much of this because SD 1.5 is determined based on the noise or the seed value, that if you were to just generate like 30 of these, some of the morphs would look really good and others would look like crap, just because it's kind of the challenge of SD 1.5. Cool. I don't have anything else. I mean, we could use the remaining 10 minutes and throw an IP adapter on this if we wanted to see like an actual, like put an actual person, an actual celebrity or someone in this video. But I don't have much else to cover if you want us to call it a day, and we can pick up more next week with some other interesting ideas or other video tools. Any last questions? Cool. I do a version with IP adapter. What I'll do is I'll find that workflow and I'll share that as well. So if anyone wants to get really crazy, and I think I threw like Keanu Reeves or something into this. So you can also look at that version as well. So I'll grab that for everybody. I think I saved this one out already. I did, right? I did. Yep. So cool. So I'll upload that to our drive folder. Cool. Well, we can just call it there. And then we'll meet again next week. And in the next couple of days, I will send out a survey of what people are more interested in covering still. So we'll do one more version of video where we'll get into more of the crazy vid to vid stuff. Like, I think what we'll actually do is we'll just load in one of like Eden's default workflows, and we'll work through like how to fix it because it's gonna be broken. And see all the craziness that they built. Like, one of the best ways to learn is just to look at someone else's workflow and be like, what the hell are they doing here? Why are they adding all these other layers into things? So we'll look at that next week. And then again, if there's other things people want to talk about, we can cover that as well. So I'll send a survey of just what else people want me to cover. Again, please vote for anything you want, because anything that we don't cover in class, I'll try to record like a little short tutorial on it. So you will still learn those things just at your own leisure. And yeah, I'll cover that in the next couple weeks. So yeah, I'll see you next week. All right.
Thank you.
Yep.
Thanks,
Bye, everybody.
Eric.
Thank you, Greg.
Bye, everybody.
Bye, buddy.
Thank you. Thank you. Goodbye.